In this question, okay, a potential is asked. But before solving the question, we'll just discuss something about potential. Okay. So I'll give you the analogy between field and potential. What is field? Field was nothing but force on unit positive charge, isn't it? Similarly, potential is nothing but potential energy of unit positive charge. Okay. Field was nothing but force on positive 1 coulomb. Potential is nothing but potential energy of positive 1 coulomb. Okay. And that potential is represented as volt. The unit of potential is represented as volt. Fair and fine. And this volt that we'll study in this chapter, next chapter means current electricity, or wherever you study volt, okay, either in capacitor or alternating current or throughout the current electricity module. Volt is nothing but, or we'll study volt as electromotive force also. Okay, sometimes it will be written as electromotive force EMF or volt. Okay, both are this more or less the same thing. It is nothing but potential energy of positive 1 coulomb. Okay, now in this question there are two rings. Okay, one of the ring is positively charged with plus q and the charge is distributed throughout the ring, and the another ring is negatively charged, the charge is distributed throughout the ring. Fair and fine. Negatively charged minus q. The center of this ring, okay, or the positive charge ring is known as A. The center of negatively charged ring is known as B. The distance between two rings is given as small a. Both the rings are given as radius of r. Okay, and one more thing I forgot to tell you, this type of setup is also known as Helmholtz coil. Okay, HEMLOTZ coil. Okay, okay. So we must find out the potential difference between point A and point T. So potential difference is nothing but VA minus VB. Okay, VA minus VB, isn't it? So what is VA? VA is nothing but you have to put positive 1 coulomb out here and find out the total potential energy on that positive 1 coulomb. So if you put positive 1 coulomb on point A, what is the potential energy due to this ring? Due to this ring is nothing but kq by r square. Sorry, not kq by r square, it is kq by r. Okay, potential, the formula for potential is nothing but kq by r. Okay, and if you put positive 1 coulomb out here, what is the potential due to this negatively charged ring? This negatively charged ring, every point in this negatively charged ring is nothing but under root of a square plus r square. That means this hypotenuse, every point in the ring is hypotenuse distance away from this point A, no? So it is minus kq by under root of a square plus r square, isn't it? Similarly, what is the potential of B? Potential of B, so that means if you have to put positive 1 coulomb out here. Okay, the potential energy due to this negatively charged ring is nothing but minus kq by r. Okay, and the potential energy due to this positively charged ring out here is nothing but plus kq by how much? Under root of a square plus r square. Now what you have to do is you have to find out the potential difference, that means VA minus VB. So VA minus VB, or potential difference between point A and B, is nothing but VA, which is equals to kq by r minus kq by under root of a square plus r square, isn't it? I wrote this entire term out here, minus of, I have to write this entire term out here, isn't it? So minus kq by r plus kq by under root of a square plus r square, isn't it? So if I evaluate this value, minus VB is equals to plus kq by r, and minus becomes plus, so plus kq by r plus kq by r is nothing but 2 kq by r. Okay, out here minus kq a square plus r square and minus kq a square by r square is nothing but minus 2kq under root of a square plus r square. This is our answer. Okay, you can take 2kq common and you can make it 1 by r minus 1 by under root of r square plus r square. Both will have the same effect. Okay, it doesn't matter which representation of the answer you write. Understood? So let's send it out. Out here, I'll tell you the similarity between field and potential. Okay, what is force exerted on positive 1 coulomb? Nothing but the electric field. Force exerted on positive 1 coulomb is known as electric field. Similarly, potential energy of positive 1 coulomb is known as electric potential. Okay, potential energy of positive 1 coulomb is known as electric potential. That will learn, or that will be termed as volt. Okay, in this chapter, in the subsequent chapter of current electricity. So whenever you hear volt, volt is nothing but potential energy of positive 1 coulomb. Fair and fine. Now what is potential energy? Potential energy is nothing but negative of work done by a conservative force. So out here, change in potential energy is nothing but negative of work done by a conservative force. Now let's read the question. In this question, what is given is that it's an infinite charge carrying wire. Fair and fine. The charge density is given by lambda. Now at distance a, okay, let this be 0.1 and this is distance a. Okay, and there is another point 2 which is at distance n into a. Now I have to find out the potential difference between 0.1 and 0.2. So can I say potential difference between 0.1 and 0.2 is nothing but negative of work done by a conservative force in bringing a unit coulomb of charge from this point to this point, isn't it? So if I look out here, okay, if I keep a positive charge out here, what is the electric field or what is the force on 1 coulomb? Force on 1 coulomb is nothing but E is equals to 2k lambda by r. Therefore work done would be equals to 2k lambda by r into dr. Now I have to find out the work done in bringing from this point to this point. Okay, so work done is equals to how much? Initial point or r1 to r2. Okay, so work done is equals to 2k lambda. What is 1 by r dr? 1 by r dr is nothing but ln r or log base to the power e into r from r1 to r2. This can be written as work done is equals to how much? 2k lambda ln r2 minus ln r1, isn't it? And ln r2 by ln r1 or ln r2 minus ln r1 can be written as 2k lambda ln r2 by r1, isn't it? Fair and fine. Now see out here. See, what was the value of r2? The value of r2 was nothing but n into a. And what was the value of r1? A. So if I substitute both these values, 2k lambda ln, the value of r2 is n into a in this specific question. And the value of r1 is a. A and a would get cancelled. So work done on positive 1 coulomb charge is equals to ln n. So work done in bringing a positive 1 coulomb from this point to this point is nothing but 2k lambda ln n. So therefore potential difference between V1 minus V2 or sorry V2 minus V1 would be minus of how much? 2k lambda ln n. Potential difference means final potential minus initial potential or V2 minus V1. Now if I multiply this minus with this term, it is nothing but V1 minus V2. V1 minus V2 would be how much? 2k lambda ln n. Now in this question you have to find out the electric field potential at the center of the hemisphere. So this is a hemisphere, isn't it? This is a hemisphere. Now this is the center of the hemisphere and I have to find out the potential at this point. That means potential energy of +1 coulomb kept out here of this hemisphere. The surface charge distribution is given as sigma. It means all the charges are situated on the surface. Fair and fine. Now, how do I find out this kind of potential? Okay, see out it. If I take an elemental ring, a shell is nothing but elemental ring. No? So if I take an elemental ring, okay, of radius, the radius out here is r, and out here this angle is theta. So this much distance is nothing but r cos theta. It means this much distance is nothing but r cos theta, and this much distance is nothing but r sin theta. R sin theta. Fair and fine. Okay. Now what is the potential due to this elemental ring out here? It is nothing but kq by r. The potential due to ring, a potential due to ring is nothing but k into dq. dq is nothing but the charge on the ring divided by r, because every point on the ring is r distance away from the center of the hemisphere, isn't it? Now I have to find out what is the value of dq. So dq is nothing but sigma into area of this elemental ring. So dq is nothing but sigma into area of the elemental ring. And what is the area of the elemental ring? Perimeter of the elemental ring into thickness. Okay, so perimeter into thickness. Out here, the thickness of the ring is given by r, or capital R, into d theta. See, r into d theta. If this angle is theta, this much angle is nothing but d theta, no? So this much distance would be nothing but r d theta. Perimeter of the ring is nothing but 2 pi r sin theta into r d theta. So area of the elemental ring is nothing but 2 pi r sin theta, that is the perimeter, and thickness of the elemental ring is nothing but into r d theta, isn't it? Or dq is equals to sigma into 2 pi r square sin theta d theta. Now if I substitute the value of dq out here, what do I get? Potential of the ring, potential due to the elemental ring is nothing but k dq. dq is nothing but sigma into 2 pi r square sin theta d theta divided by r. R and r square would get cancelled. Fair and fine. Now I have to integrate sin theta d theta. From where to where? See, I have to integrate this sin theta d theta. If I integrate from 0, theta is equals to 0, that means from the top to theta is equals to 90, that means out here the ring, the small ring at the top to the entire ring at the equator. So from theta is equals to 0 to theta is equals to 90, pi by 2. So k sigma 2 pi r into integration of sin theta is nothing but minus of cos theta, isn't it? From 0 to pi by 2. I can take this minus outside, or VV, potential due to ring, is nothing but minus k sigma 2 pi r into cos theta. Or what is cos pi by 2? Cos pi by 2 is nothing but 0. Minus of what is cos 0? 1. So it is nothing but minus 1. So potential due to the entire hemisphere. See, when I integrated from 0 to pi by 2, I got the potential of the entire hemisphere, no? Okay, if I integrate the ring from 0 to pi by 2, okay, I'll get the potential of the entire hemisphere. So out here, instead of doing potential of the ring, I'll do potential of the hemisphere, or out here, hemisphere. So potential of hemisphere is nothing but this minus 1, and this minus 1 would get turned into positive. So k sigma 2 pi r. Okay. Now I also have to find out the electrical field at this point due to this ring. Okay. Now, what is the formula for electric field due to a ring? The formula for electric field due to a ring was given by electric field due to ring was given by how much? K dq x is nothing but r cos theta by how much? R square plus x square. So r sine theta r square sine square theta plus r square cos square theta into 3 by 2 into 3 by 2. See, if you are confused about where I got this formula, okay, this formula is nothing but potential or electric field due to a ring was how much? Kqx divided by r square plus x square to the power 3 by 2, no? Out here, what is the value of r? The value of r is nothing but r sine theta. What is the value of x? The value of x is nothing but r cos theta, isn't it? So r square plus x square to the power 3 by 2. So kqx x divided by r square plus x square to the power 3 by 2. Remember the formula for electric field due to a circular ring on the axis. That is the same formula I am using out here. Okay. So out here, if I take r square common from these two terms, okay, sine square theta plus cos square theta is equals to 1. So I'll get r square out here, r square to the power 3 by 2, r square to the power 3 by 2. 2 and 2 would get cancelled. It would become r cube, isn't it? Become r cube. R and r cube would get cancelled to become whole square. So this would become r whole square. Now electric field due to the ring is nothing but k. What is the value of dq? The value of dq is nothing but sigma into 2 pi r square sine theta d theta divided by r square. Now if I cancel this out, similarly potential due to ring, sorry, electric field due to ring is nothing but k sigma 2 pi into sine theta d theta. Similarly, I have to integrate from 0 to pi by 2. And if I integrate sine theta from 0 to pi by 2, what do I get? Minus 1. So out here, electric field due to ring is equals to minus k sigma into 2 pi. This minus out here signifies the direction of electric field. That means the direction of electric field would be downward. Okay, because out here x, this x, what is the x? In the formula, x was taken as r cos theta or positive r cos theta, no? So upward direction was taken as positive. So downward direction would be negative, or the electrical field would be in downward direction. Okay, along this direction. Fair and fine. Now, in this question, there is a circular disc. Okay, and this circular disc is kept in this plane. I have to find out the electrical field on the axis of the disc. So suppose there is an axis on the disc. I have to find out the electrical field and potential at out here. So let this distance be x and the radius of the disc be r. So by now you already have got the idea that you have to take the components. And how do you have to take the components? Convert all perpendicular and hypotenuse terms into base and angle, isn't it? We have done this kind of situations before. So out here, this disk has charge density sigma. And how do I integrate disk? Disk is nothing but integration of rings from 0 to r. So if I take an elemental ring out here, okay, of radius y and thickness dy, okay, the electric field due to this elemental ring would be in this direction, e ring. Now if you observe properly, okay, see, the y and z component of electric field would get cancelled. Why? See, down out here, the electric field would be upward or in this direction. Out here, the electric field will be away from you. Out here, the electric field would be towards you. So if I take all the components, okay, or if I take all the components along this line, the electric field of the ring would get cancelled out by each other. That means the topmost portion of the or top portion of the ring would cancel out the bottom portion of the ring. Okay, so y component of electric field gets cancelled. So what we are left with is the remaining x component of electric field. And how do I calculate x component? Let's name this angle theta. So if this angle is theta, this is directly opposite. So this angle should be also theta. So Ex is nothing but Er cos theta, isn't it? Ex is nothing but the electrical component or electrical field in x component. Is nothing but electrical field into cos theta. Now what is Er or electrical field due to ring? Electrical field due to ring is nothing but K dq. Dq is nothing but charge on the ring divided by r square. Out here, r is nothing but the distance of the ring to the point. This is nothing but let this point be h. Let this variable be h. Anyways, I have to convert this h into x and theta. Okay, h square into cos theta, isn't it? Okay, so before converting h, what is the value of dq? Dq is nothing but charge on the ring. Okay, and charge on this ring is nothing but charge density into area of the ring. So charge density into what is the area of the ring? Perimeter of the ring into thickness. Perimeter of the ring is 2 pi y and thickness is dy, isn't it? Now see out here. So some more substitution. See, already have got the idea that out here how do you have to substitute? You have to substitute h. Okay, h is equals to how much? H or hypotenuse. Okay, you have to convert all the hypotenuse terms and perpendicular terms in terms of x and angle theta. So can I say cos theta is equals to x by h? So cos theta is equals to x by h. X by h is equals to cos theta, or h is equals to x into sec theta. Okay. Similarly, I have to convert y also. Y. Okay. So tan theta is equals to y by x, or y perpendicular by base y by x is equals to tan theta. See out here. Theta, tan theta is equals to perpendicular by base. Okay. Or y is equals to x tan theta. Fair and fine. And the third portion is I have to differentiate this one. So dy by dx. Dy by dx is equals to x sec square theta, or dy is equals to x sec square theta into dx. I have to substitute all these terms in this equation. So x component of electric field, or Ex, is nothing but k into sigma into 2 pi. I'm directly substituting. Okay, k sigma into 2 pi. What is the value of y? The value of y is nothing but x into tan theta. So x tan theta into what is the value of dy? Dy is nothing but x sec square theta dx. So x into sec square theta dx divided by hypotenuse square. Acha, I have done dq out here. This entire term was dq. Okay, dq is nothing but this term. And take cos theta also, no? So into cos theta. This cos theta I was forgetting out here. Okay, divided by h square. What is the value of h? The value of h is nothing but x into sec theta. So therefore h square is nothing but x square sec square theta. So out here sec square theta would get cancelled. X and x would become x square. This would get cancelled. So you are left with nothing but this got cancelled. X. See, tan theta into cos theta is nothing but sin theta. So out here tan theta and cos theta would become cancelled to become sin theta into dx. Let me write this dx out here. And if I integrate this ring from theta is equals to 0, okay, to theta is equals to this value, I'll get the value of electrical field due to the circular disc, isn't it? So at, okay, so Ex, the electrical field, is equals to K sigma 2 pi into what is the integration of sine theta minus of cos theta, minus of cos theta. I'm taking this minus outside. And what is the lower limit? 0. See, I have to start integrating from out here, no? I have to reach out here. What is the value of cos theta out here? The value of cos theta at the extreme position, or at pi is equals to r, would be nothing but cos theta. Cos theta is equals to how much? Base by r square plus x square, isn't it? Under root. That is nothing but the hypotenuse at extreme. So theta is equals to cos inverse x by under root of r square plus x square. Okay, you can do this type of integration algebraically also, but since I already taught you regarding angles, okay, we'll use the generalized formula only. Okay, we won't go to the integration or algebraic integration. Learn one method and try to stick to it. Okay, because many times, see, out here, fortunately, your algebraic equations will work or algebraic integration will work, and it is much easier. I know that. Okay, but since you have learned a straight line, since you have learned all those things, right now you can make or you can take integration with angles, you know. So practice integration with angles in this chapter. It will be very good for you. Okay. So 2 cos inverse x by under root of r square plus x square. So electrical or x component of electric field is nothing but minus k lambda 2 pi into x by under root of r square plus x square minus cos of 0. What is cos of 0? 1. And if I multiply this minus inside this bracket, okay, if I multiply this minus inside this bracket, it would be Ex is equals to how much? K sigma 2 pi into 1 minus x by under root of r square plus x square. So this is the value of electric field. Now what we'll try to do? We'll try to find out the potential. Okay. So for potential due to ring. So now we'll try to find out the potential. For potential. Okay. Potential due to ring is nothing but K dq by hypotenuse, isn't it? Okay. For V ring, potential due to ring is nothing but K. What is the value of dq? Sigma 2 pi y dy is the value of dq divided by hypotenuse. Divided by hypotenuse. What is the value of hypotenuse? Hypotenuse is nothing but x sec theta. X sec theta. Asha. We'll convert this y dy into this x tan theta and x into sec square theta d theta, not dx out here. It should be d theta out here. See, if you multiply or if I differentiate with respect to theta, so there is an error I made out here. Okay. So similarly, V ring is simply but k sigma 2 pi. What is the value of y? X tan theta. What is the value of dy? X sec square theta d theta by x sec theta. See, now x and one of the x would get cancelled, sec theta and sec square theta would get cancelled. Okay, tan theta into sec theta is nothing but sine theta. Okay, tan theta into sec theta is nothing but sine theta. So to get V ring or potential due to ring is nothing but k sigma 2 pi x into tan x into sec x. or is equals to sine theta d theta. Now some of you might have problems that is in the y component of potential getting cancelled. Potential is a scalar quantity. Okay, potential is not a vector quantity. So there is no y component or x component or z component of potential. Okay, potential will be directly added. From theta is equals to 0 to theta is equals to this value. Okay, so we'll do this on the next page. See, I made a little bit of error out here. Instead of dx, write d theta. Okay, sine theta d theta. Okay, this would be d theta instead of dx d theta out here. So now I have found out the potential of the ring is equals to this value, the integral of sine theta d theta. From theta is equals to 0 to theta is equals to this value, to theta is equals to cos inverse this value. So when I integrate sine theta d theta from 0 to this value, what do I get? I get 1 minus x by under root of r square plus x square. No, I'll get this value. See, follow the integration, isn't it? I'll get this value. So if I say sine theta d theta is nothing but this value, so can I say potential due to ring is nothing but k sigma 2 pi x into integration is nothing but 1 minus x by under root of r square plus x square. You do not need to do the same integration again and again. No. Yeah. In this question, okay, there is a circular disc out here, and this disc has a charge distribution of sigma, a surface charge distribution of sigma that is given in the question. Okay, we have to find out the potential at the circumference of the disc due to all these charges. Okay, so you get the intuition that we have to integrate out here. Now tell me how many ways are there to integrate a disk. Okay, primarily you know of two ways. First one is, now look at all the ways we integrate a disk. Okay, the first method, is we take an elemental ring, okay, of radius r and thickness dr, and area of the ring is nothing but area of ring is nothing but perimeter of the ring 2 pi r into thickness of the ring dr. And now when we integrate that area of the ring from 0 to radius of the circle, but capital R is nothing but radius of the disk. Okay, we get the area of the disk, which is pi r square. Fair and fine. What is the second method? The second method is we take an elemental pi. Okay, and we find out the area of the pi. So area of pi. So area of pi is nothing but area of this much portion, but this angle is d theta. So how do I find out the area of the pi? Let's take an element. Okay, let's take an element of thickness r, thickness dr, at radius r. Okay, the thickness of this line is dr. Okay, at radius r I'm taking a line of thickness dr. What is the length of this line? The length of this line is nothing but r into d theta. So area of this line, or area of element, is nothing but length, which is nothing but r into d theta into thickness, and thickness of the element is nothing but dr. And when you integrate this function from 0 to capital R, we get the area of the pi. That means length into thickness is nothing but the area of this element. So length is nothing but r d theta. Out here length is nothing but r d theta, and thickness is nothing but dr. Okay, so r d theta into dr, when you integrate this line from 0 to r, you get the area of element. So area of the element is nothing but r square by 2 d theta. This is the area of pi, or area of pi. So area of pi is nothing but r square by 2 d theta, where r is nothing but radius of the circle or radius of the disk. Now if I integrate this pi from 0 to 2 pi, that means this d theta is nothing but radians, no, or degrees. So if I integrate this function from 0 to 2 pi, I'll get the area of the disk, which is equals to pi r square. Pi r square. Similarly, if I integrate from 0 to r, I'll get the same formula, pi r square. Okay. Now the third method of integrating a circle is the point we use out here, or is the parameter that we use out here. Okay, in this specific problem. Now listen to the third method very carefully. Okay, third method. Okay, this is a circle. Okay, or this is a disk. Now instead of taking our pi from the center, we'll take our pi from the circumference. Okay, I'll take pi from out here. So let's draw a diameter. Diameter always passes through the center, and the length of diameter is 2r, or twice of radius. Okay, now let's draw an angle theta out here, and this angle is d theta. This is d theta. Okay, how much is this much angle? See, in properties of a circle, you know that if a triangle is formed by joining two ends of a diameter and a circumference, that means this angle is always 90 degree. It doesn't matter where this line joins a portion. That means this line is connected out here or out here. It doesn't make a difference, because this thickness or this length is already so small, no? Because this is d theta. Understood? So this angle will make 90 degree, irrespective this line joins at lower portion of the pi or topmost portion of the pi. Okay, and I have to find the area of the pi. I have to find out the area of the pi. Okay, this is d theta. Okay, what is this much length? This much length is nothing but this is 90 degree. This is 2r. So can I say this much length is nothing but 2r into cos theta, because this is already 90 degree. So 2r cos theta. So 2r cos theta. Okay, is this much length. Okay, and how do I find out the area of this pi? So area of the pi is nothing but I take an integral length out here, or elemental length out here. Okay, at radius r of thickness dr. Okay, I use the same method that I used out here. So what is the area of the element? Area of element is nothing but r d theta. That is the length of the element. That is the length of the element into thickness into dr. So r d theta into dr. This is the length of the element. This is the thickness of the element, and this is the area of the element. Now if I integrate this element from 0 to 2r cos theta, what do I get? I get the area of this pi, no? I get the area of this pi. Okay, so area of pi is nothing but r square by 2 into d theta. Now the limits of integral are from 0 to 2r cos theta. Okay, out here it was 0 to r, no, but out here it is 0 to 2r cos theta. Why? Because out here we integrate from 0 to r, but out here we will integrate from 0 to 2r cos theta. Okay, so area of pi is nothing but 4r square cos square theta by 2 into d theta. So 2 and 4 will get cancelled to form 2. Okay, so area of pi is nothing but 2r square cos square theta into d. Now see, if I integrate this pi for the entire circle, how did it look like? So I'm clearing out the diagram a little bit. Okay, so if I integrate this pi for the entire circle, okay, this pi this pi. So if I have to integrate the entire circle, it would look somewhat like this. That means I have to integrate all these pi's. Okay. So that means my angle is going from minus pi by 2. If I'm starting from here, at theta is equals to 0, I'll get half the same or half the disk. Okay. At theta is equals to minus 90, I'll get the entire disk out here. At 2 theta is equals to plus 90. So area of disk is nothing but 2r square cos square theta d theta from minus pi by 2 to pi by 2, or minus 90 to plus 90. See out here. The first method was integrating a ring from 0 to capital R. So if I integrate a ring from 0 to capital R, we get pi r square. The second method is integrating a pi for entire angle 2 pi. So area of pi is nothing but r square by 2 d theta. I've already derived out here. Or area of pi is derived by length into thickness. So r d theta into dr, which gives r square by 2 d theta. And if I integrate this pi from 0 to 2 pi, I'll get pi r square, isn't it? The third method is, instead of taking our pi from center, we'll take our pi from the circumference. Okay, so area of the pi is the same method that we used out here. Thickness or area of the elemental length, that is r into d theta, r into d theta into thickness, r d theta into dr. You have to integrate that from 0 to 2r cos theta, 2r cos theta. So I'll get the area of this pi. Okay, and if I integrate this pi from minus 90 to plus 90, I'll get the area of the disk. Is that understood? Now check out here. I'll just follow with a little bit of mathematics out here. Okay, integration of c out here. When I'm integrating this pi from minus pi by 2 to plus pi by 2, or from minus 90 to plus 90, 2r is already a constant, so I have to integrate cos square theta d theta, no? So that is a mathematical part. So out here I'll integrate cos square theta into d theta. Okay, so cos square theta into d theta, to integrate cos square theta into d theta, we have to convert them into terms of cos 2 theta. See, if I say cos 2 theta, cos 2 theta means cos theta plus theta, which is nothing but cos square theta minus sin square theta. See, cos A plus B is nothing but cos A cos B minus sin A sin B. So cos theta plus theta is nothing but cos theta minus sin theta. And you already know sin square theta plus cos square theta is equals to 1. Okay. So sin square theta can be written as 1 minus cos square theta. So sin square theta can be written as 1 minus cos square theta, isn't it? Because cos square theta plus sin square theta is equals to 1. So if I substitute out here, okay, I'll get 1 minus cos square theta. Okay, now see, this cos square theta and this cos square theta would get added, minus and minus becomes plus, so it will become 2 cos square theta minus 1. So this entire term would become 2 cos square theta, 2 cos square theta minus 1. I'm just playing mathematics out here. Okay, so if I send the 1 to the left hand side, or cos 2 theta plus 1 is equals to 2 cos square theta. Okay, or divided by 2, cos square theta is equals to cos 2 theta plus 1 divided by 2. So instead of writing cos square theta, I'll use the differentiation, which is equals to cos 2 theta by 2 into d theta plus 1 by 2 into d theta. Okay, so you can already separate these two terms and write it as this one, no, cos 2 theta by 2 plus 1 by 2. So cos 2 theta by 2 d theta plus 1 by 2 d theta. Understood? So integration of, I'm just erasing all this part. Okay, integration of cos 2 theta by 2 is nothing but sine 2 theta by 2, isn't it? And this will get multiplied by 2. This 2 gets multiplied by this 2. Okay, and d theta is nothing but plus theta. isn't it? So our integration will give the result of sine 2 theta by 4 integration or limits plus theta. Okay, I can put the limits out here. Our area of the disk is nothing but 2r square, 2r square into sine 2 theta by 4 from minus pi by 2 to pi by 2. Okay, plus theta from minus pi by 2 to pi by 2. Okay, see, sine 2 theta or sine 2 into 90 is sine 180. What is the value of sine 180? 0. Sine 2 into minus 90, so sine minus of 180, sine of minus of 180 is also 0. So 0 minus 0, this entire term would become 0, isn't it? This term pi by 2 minus of minus pi by 2 is nothing but pi by 2 plus pi by 2, which is nothing but pi. So this term will become pi. So okay, okay, fair and fine, which is equals to pi r square or 2 pi r square or 2 pi r square. Acha, I made an error out here. See, by 2, I haven't done by 2 out here, no? Theta by 2. Okay, theta by 2. I've integrated this d theta. See the mistake I made out here. Okay, I've integrated this d theta. Okay, integration of half d theta is nothing but theta by 2. So out here I'll get theta by 2. Theta by 2. This is just calculation mistake. Okay, so I'll get, instead of pi, if I use theta by 2, I'll get pi by 2. Pi by 2. Okay, the main thing you have to remember out here is there are three ways to integrate a circle. First one is ring, the second one is pi, the third one is taking pi from the circumference. Okay, and we'll get the same answer, pi into pi by, or which is equals to, if you get pi by 2 out here, which is nothing but 2r square into pi by 2, which is nothing but pi r square, which is the same area of the disk. So there are three ways of integrating a disk. Understood? This was the main concept that I'm using. Achha, one more thing. In this question, we'll use this concept. Okay. Okay. Sir, why aren't you using this concept or this concept? See, if you use this concept, okay, or if you take elements like this, we'll get stuck in the integration. Okay, the limits or the area under the limits will be infinite. Okay. The same thing happens when you take the limits out here. The thing that evades us is when you take the limits like this. When you take the limits like this, no complications of integration arises. Okay, that's why you're taking the limits out here. You'll understand in a matter. Okay, now in order to find out the potential out here due to this entire charge distribution, we have to take an element, isn't it? So my element out here would be a pi. So I'll take an element pi. Okay, this angle is theta, this angle is d theta. Okay, and I have to find out the potential at this point due to this all the charges situated on pi. Understood? Where the angle of the pi was d theta and this angle was theta. What is the length of this pi? 2r cos theta. Why? Because this angle is 90 and this angle is 2r. Fair and fine. Okay, so if I take an element out here, if I take an elemental length out here, this is nothing but r, at radius r, and the uh, thickness of this elemental length is nothing but dr. Okay, what is the potential due to all these charges out here? The potential due to all these charges out here is nothing but potential at this point. Okay, potential at this point due to this much charges is nothing but k dq by r, isn't it? Dq is nothing but charges situated in this much element, and r is nothing but distance from the element. Okay, the value of dq is nothing but sigma into elemental area, the surface charge density into elemental area. And what is the elemental area of this much length? The elemental area of this much length is nothing but r d theta, that is the length of this element, into thickness. Thickness is nothing but dr, isn't it? And I have to integrate this from 0 to 2r cos theta, 0 to 2r cos theta. So if I integrate this function from 0 to 2r cos theta, 2r cos theta, I'll get the potential at this point due to all the charges situated in this point, due to all the charges situated in this point. Understood? So instead of applying the integral out here, I'll just apply the integral out here. Okay, or v is equals to k, which is equals to 1 by 4 pi epsilon naught into sigma into r d theta dr by r. Okay, from 0 to 2r cos theta, isn't it? R and R fortunately got cancelled out here. Okay, if you did by any other method, now if you took an elemental ring and did the same thing out here, you would get stuck into integration. Okay, 1 by cos theta, and the integration of 1 by cos theta from the limits would be infinite. That means somewhere around the line or somewhere around the integration, the area under the integral is infinite. Okay, just try it out for the homework. Okay, take an elemental ring and try to do the same formula or try to do the same thing. Okay, or v is equals to k sigma into d theta. These are constant, no? And to integrate dr from 0 to 2r cos theta, 2r cos theta. So integration of dr from 0 to 2r cos theta is nothing but 2r cos theta itself, isn't it? This becomes 2r cos theta. So potential due to this pi is nothing but k sigma d theta into 2r cos theta, where r is the radius of the disk. Fair and fine. Now I have to integrate all the pi from minus pi by 2 to plus pi by 2. So potential due to disk is nothing but k sigma 2r cos theta d theta. Okay, from minus pi by 2 to pi by 2. Or potential of disk is nothing but k sigma 2r. What is the integration of cos theta? Sin theta from minus pi by 2 to pi by 2. Sin 90 is nothing but 1 minus of sine of minus 90. Sine of 90 minus 90 is nothing but minus 1. So 1 minus of minus 1 becomes nothing but 1 plus 1, which is nothing but 2 out here. So potential due to the entire disk is nothing but, okay, 2 or k sigma 2 into 2, this 2 and this 2 becomes 4 into 4r, or is equals to 4, or potential due to the entire disk, potential due to the entire disk is nothing but 4 sigma kr. Okay, fair and fine. Now I'll tell you the approach why I haven't taken the elemental ring out here or the elemental pi from the center. Okay, in both cases what will happen is, see, I'll tell the analogy, or the point where you get stuck if you take elemental ring or you take pi from the center in this question. Okay, so I'll quickly revise all the types of integration that you have done up till now, and these are the fundamentals of integration that will be applied throughout your entire physics. Okay, this is not only valid for this chapter, this is valid for entire physics. So whenever there is a straight line, whenever you have to integrate a straight line at distance y, okay, at this point, what do? You take an elemental dx at position x and this is hypotenuse. Okay, and this is theta. So what did I say? Convert all the vertical and hypotenuse terms in terms of y and theta. A proper definition would be convert all the variable terms. Variable terms means out here what are the variable terms? X, dx and h are variable terms in terms of y. See, as I'm going up, y is not changing, no? Say constant y and theta. So convert all variable terms or variable lengths in in terms of y and theta. That means convert all vertical and hypotenuse terms in terms of horizontal length and theta. See, if I just tilt this diagram, the vertical and horizontal won't be the same, no? The main definition you need to remember out here is convert all the variable terms, variable lengths. Length is x variable, dx is a variable, and h is a variable. As I go up, h varies, x varies, and dx varies. So convert all the variable lengths in terms of y, which remains constant, and theta, which also remains variable. Okay, and this type of integration is also applicable for a disk kept in z-axis. You have to find out potential or field at in the axis. Okay, out here this is r, this is dr thickness. Okay, and how do we do that? The first method is tan theta is equals to x by y. So x is equals to y tan theta. You already converted x. Now if I differentiated this, dx by d theta is nothing but y sec square theta. Okay, or dx is equals to y sec square theta into d theta. Some of you might have made the habit of making a mistake that dx is nothing but h into d theta. Do not make that one, or do not make that mistake. Out here, this is not a circle, so you cannot make dx is equals to h into d theta. Understood? You have to differentiate this term and find out the value of dx. The third one is how do I convert hypotenuse? To convert hypotenuse, cos theta. Cos theta is equals to y by h, or hypotenuse is equals to y by cos theta, or y into sec theta. So whenever there is a line, you have to integrate a variable out here or a point out here. Okay, convert all the variable lengths, that means the vertical and hypotenuse, in terms of a fixed horizontal length and theta. See, all I'm saying is do not focus on the word vertical and horizontal. Okay, if I just rotate this diagram, the vertical and horizontal would interchange their position. The main concept out here is convert all the variable lengths in terms of y and theta. Understood? The second portion, how do I integrate a disk? So the integration of disk we have seen. Okay, how do I integrate a ring? Integration of ring is nothing but take an elemental length out here. The length out here is nothing but r into d theta. Okay, theta, this length is nothing but r d theta. Okay, and the length of the entire ring is nothing but r d theta. You have to integrate from 0 to 2 pi. So length of ring is nothing but r d theta from 0 to 2 pi. Okay, similarly, if a disk is given, this I've already discussed in the previous question. Okay, those are the three ways you can integrate a disk. Now suppose a shell is given. Okay, a hollow shell, that means there is nothing inside. Okay, how do I integrate a shell? The method of integrating a shell is nothing but take an integral ring out here. Okay, the length of this ring is nothing but r d theta. R d theta, how? This is nothing but radius r, this is nothing but theta, and this is nothing but d theta. That means this angle is nothing but d theta, this angle is theta, and this is r. The radius becomes, this length becomes r sine theta, r sine theta, and this length becomes r cos theta. Okay, so how do I find out the surface area? Area of ring, area of elemental ring is nothing but perimeter of the ring. What is the perimeter of the ring? 2 pi into r sine theta or r sine theta. This is the radius of the ring, na? The radius of the ring is r sine theta, not capital R, isn't it? So radius of the ring is, or area of the ring is 2 pi r sine theta, or perimeter of the ring, into thickness. What is the thickness? Into r d theta, r d theta. So this is perimeter of the ring. This entire thing is perimeter of the ring. This is thickness. So this is the length of the ring into thickness. Okay. Similarly, if I integrate, or area of shell is nothing but I have to integrate this entire function r square sine theta into d theta from 0 to asha, from 0, from theta is equals to 0 to theta is equals to pi. Okay, from 0 to pi. See, at 0, at this theta, I am taking this entire area, no? So if I integrate from 0 to pi, I'll get the entire shell. Understood? Now similarly, we'll get area of the ring is equals to, sorry, area of the shell. Area of shell is equals to 4 pi r square. Fair and fine. Now solid sphere. How do I integrate a solid sphere? Solid sphere I'll do downward, or I'll do out here. Solid sphere. Now there are basically two ways of integrating a sphere. The first one is taking an elemental shell. So if I take an elemental shell out here of radius r and thickness dr. Okay, what is the area of the shell, or volume, not area, when I'm integrating a sphere or solid sphere? Okay, I have to find out the volume. So volume of elemental shell is nothing but 4 pi r square, which is the surface area of the shell, into dr, thickness of the shell. So volume of sphere is nothing but integration of this entire thing from 0 to r, which will give you 4 by 3 pi r cube. 4 by 3 pi r cube. Okay, there is one more way you can integrate a shell. Sorry, not shell, a sphere. Okay, see, the second method of integrating a sphere is nothing but, this is a sphere. Out here, our element would be the elemental disk out here. Okay, elemental disk out here, and this is r. Okay, r cos theta. This is theta. This is r sine theta. This length is nothing but r d theta, r into d theta. So volume of the disk, volume of the disk, volume of the disk is nothing but area of the disk. What is area of this disk? Area of this disk is nothing but pi r square, or pi r sine theta square. So pi into r sine theta whole square into length. Out here, while taking the length, do not make a mistake of directly putting r d theta. Okay, don't make this mistake. We have to take the vertical component of this length. That means we have to take the height. See, the r d theta, the length is along this line, no? We have to take the length along this line, or vertical line. So if this angle is theta, that means this angle is also theta, isn't it? So this is nothing but 90 minus theta. So r d theta cos 90 minus theta. Okay, so r d theta sine theta. So the height would be r d theta sine theta. Okay, or vertical component of height. Vertical component of height. Vertical component of length. This is area of the ring. Area of disk into vertical component of length. That means the height. Height is nothing but vertical component of length. And if I integrate this entire thing, that will give us the volume of sphere. Volume of sphere is nothing but pi r square sine square theta. Okay, pi r square sine square theta into r d theta sine theta to r d theta sine theta. And I have to integrate the shell from 0 to pi. From 0 to pi. And we'll get somewhat like the volume of the shell is nothing but we'll get the same answer 4 by 3 pi r cube. I'll just briefly show the mathematics of this. Okay, see, I'll just show the briefly the mathematics of integration of this function. Nothing but just the integration or mathematical part. Okay, so out here sine square theta and sine theta become sine cube theta d theta. Now in trigonometry I have broken up sine cube theta into sine square theta sine theta. Sine square theta can be written as 1 minus cos square theta because sine square theta plus cos square theta is equals to 1. So I have written this term. So I have substituted this term in place of sine cube theta and I have integrated this one. Now this part I am integrating by integration by substitution, where cos theta is equals to t. So minus sine theta is equals to dt by d theta, or minus sine theta d theta is equals to dt. I just substituted sine theta d theta I bought from here. This entire term was substituted by t square dt. See, if we substitute out here by this term and this term, we get t square dt, and this negative gets changed into positive because out here, because of this minus. Now, okay, if I integrate sine theta, it is nothing but minus of cos theta. I bought the minus outside. Okay, and if I integrate t square dt, it is nothing but t cube by 3. What was the value of t? Cos theta. So cos cube theta by 3. I have to integrate from 0 to pi. So pi r cube, which is already a constant, minus cos pi is nothing but minus 1 minus of cos 0, 1, plus cos cube pi. Cos cube pi is nothing but minus 1 by 3 minus of cos 0, 1 by 3. So it is nothing but pi r cube 2 minus 2 by 3, which is equals to 4 by 3 pi r cube. Okay, so all have you learned is the way in which the integrals are taken, and remember these integrals throughout your entire physics. Okay, the basic fundamental, not fundamental, these are most of the advanced question that you face will comes from this integral only. Okay, there is some differentiation, there is some optimization of differentiation that will be taught on case to case basis. But the fundamental of integrals are this much only. Okay, I don't think there is anything outside. Yeah, there are cones, there are things that will be taught in while I'm teaching rotational motion, how to take moment of inertia of complex subjects. But these are the fundamental of integrals. That's all. If I tell you how to take an integral of a square plate, how do you take the integral of a square plate? Simple, just take an elemental length. Okay, so area is nothing but length into thickness and integrate the thickness over the entire width. Understood? How do you integrate a line x dx from x to from dx is equals to this length to this length? That's the integral of a line. And what else? So these are just basically the fundamentals that you have to learn. Okay, throughout your entire physics.